All right, Julia is in the cereal aisle at the grocery store and is looking at the cereal options. The probability that the cereal is in a bag is 0.8. So I'm going to just draw this. So we have a bag. Probability that it's in a bag is equal to 0.8. That whole circle is 0.8 or 80%. The probability that the cereal has a prize inside is 0.3. All right, so we have this prize. Probability that it has a prize inside is equal to 0.3. The probability that the cereal is in a bag and has a prize, so in a bag is blue and it has a prize is black, so that overlap right here, this intersection where it's in this blue circle, probability of it in a bag, and it having a prize right there, that this whole intersection is 0.2 or 20%. So use the addition rule to determine the probability that the cereal is in a bag or has a prize inside. So what we want to find out is we want to know the probability that it's in a bag plus, or, since it says or, it can be the entire probability that it's in a bag or it has a prize inside. It can meet either of those requirements. So the probability of it being a bag is all in blue right here. And we know that this whole area, including the ones that have prizes inside, this whole area is 0.8. So notice that this overlap area is counted once already. It already counts it once. So now if we take the probability of it being a prize, which is this whole area right here, including that overlap again, is 0.3. So that overlap again was counted. So that is why we subtract out that overlap, is because that overlap was counted 2 times. So we're going to subtract out that overlap where it was the bag and it had a prize, because it was counted in this probability and it was counted in the probability of it being a prize. So that's why we subtract it out. So this is going to equal 0.8 plus 0.2 is 1.1. And then you subtract out that 0.2 and it comes back down to 0.9. So our answer is 0.9. And that's how you would answer this question using that subtraction rule. Another way I want to show you really fast, just using this Venn diagram, is to realize that if this portion of the bags is 0.2 and the total has to be 0.8, that means that this whole portion that's not in that overlap is 0.6, because then this whole circle right here has that 0.2 plus that 0.6, which is a total of 0.8. And then we could also find out just the probability that of the cereals that had prizes inside and weren't in bags. So notice that the prizes inside is already 0.2. The total, though, has to be 0.3. So this whole probability that they have a prize inside and are not part of being in a bag is 0.1. So that this total area of this circle of having a prize inside adds up to 0.3, because 0.2 plus 0.1 is 0.3. So another way you could think of it is, well, if we know the probability of it just being a bag with no prize inside is 0.6, so probability of a bag, no prize, is equal to 0.6. And then the probability of it being a bag with a prize is equal to 0.2.
I want to see it. I want to see this part.
And the probability of it being a prize and not in a bag is equal to 0.1. So if you look at that, 0.6 plus 0.2 is 0.8 plus the probability of 0.1 is 0.9. How does that meet the requirement that the cereal is in a bag or has a prize inside? Well, if I pull in this just blue area, the bag with no prize, does it meet the requirement that it was in a bag or has a prize inside? Yeah, it was in a bag. So that probability is good. If we go to this intersection right here, the probability that it had a bag with a prize inside, did it meet this requirement? Was it a bag or has a prize inside? Yeah, it met both of them. So that probability is good. We're going to include that. So then if we go to this probability that it's a prize that's not in a bag, did it meet these requirements? Yes, because was it in a bag or has a prize inside? It wasn't in a bag. It did have a prize inside. So it didn't meet that requirement again. So that's why we include that probability. So that's another way to look at this visually. If you are a visual learner instead of just using the algebraic way.